So our fourth question is, use Euclid division lemma to show that square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. So let us take a is any positive integer and b is equal to 3. So just we take 3 because we have to prove a is of the form, square of the number is of the form 3m and 3m plus 1. So we can take b as 3. So if b is equal to 3, what are our possible r? 0, 1 and 2. We cannot take 3 because r should be less than 3. If r is equal to 0, a will be bq plus r, b is 3, so 3q plus 0, that means 3q. So this is our first a. If r is equal to 0, a will be 3q. Now what is our question? Square of an integer. So we can find the square. A square is equal to 3q square. So what will be 3q square? 9q square. So this 9q square we can write as 3 into 3 into q square. Okay. In the next step we can write as 3 into 3q square. So what is q? Q is any integer. So q square is also another integer. So 3 into 3q square, where q is any integer. So instead of 3q square, we can write as m. Here m is equal to 3q square. Why we can write m? Because n is any integer. If q is integer, q square is also an integer. So 3q square is also another integer. So just keep in mind that m is any integer. So we can write a square is equal to 3m, where m is any integer. Now, next case, now we take r is equal to 0. First case we finished. Now next our r is equal to 1. If r is equal to 1, what will be our a? A is equal to bq plus r. That means 3q plus r here 1. Now what we have to find out? A square. A square is equal to 3q plus 1 whole square. So according to a plus b the whole square identity, we can write this as 9q square plus 6q plus 1. Now from these two terms, 3 is common. So we can rewrite this as 3 multiply. Here it will be 3q square plus here it will be 2q plus 1. In these two terms, just we take out 3 outside because 3 is common in 9 and 6. So just take out 3 from these two terms. We will get 3q square per 2q. So what is our q? Any integer. So 3q square is another integer and 2q is another integer. So instead of this, we can write as m. So it will be 3m plus 1. Remember, this m indicates just an integer, not its value. Just any integer. So a square can be written as 3m plus 1. So our next step finished. Now we have one more case is there when r is equal to 2. If r is equal to 2, our a is equal to bq plus r. So 3q plus r here 2. Now what we have to find out? Square. A square is equal to 3q plus 2 the whole square. Same a plus b the whole square identity, we will get 9q square plus 12q plus 4. Now here what I am going to do is, I will rewrite this as 9q square plus 12q plus, just split up this 4 as 3 plus 1. Now we can see 3 is common in this term, and this term. So just take out 3 from all these 3. So 3 take out from here. So here it will be 3q square plus here it will be 4q plus here 1 plus this 1. So just I take out 3 from all the 3 term and rewrite the sentence. So from 9q square, if take out 3, it will be 3q square. Here it will be 4q and here it will be 1. Now as the same step we done before, if q is an integer, 3q square is an integer, 4q is an integer, and all together will be an integer. So this all together again we can write as any integer m. So this can rewrite as 3m plus 1. So a square can be written as 3m plus 1. So what we have got in the first step, we got a square as 3m. In the second step, where m is any integer. And in the second step, we got a square is equal to 3m plus 1, where m is any integer. Now in the third step, we got a square is equal to 3m plus 1, where m is any integer. So what we can conclude, square of any positive integer can be written as 3 multiply any integer plus 1 or 3 multiply any integer. 3m, that means the square of any number can be written as 3 multiply any integer or 3 multiply any integer plus 1. So now let us see this theorem with an example. In first case, we can just take any positive integer. Let's take a as 6. So what will be a square? A square will be 36. So now according to this theorem, this number 36 can be written as 3m or 3m plus 1. So let us see 36. 36 can be written as 3 into 12. So 12 is an integer. So this is of the form 3m. Okay. Now let us take a is another positive integer. Let a take 10. So what will be a square? A square will be 100. So 100 cannot be written as 3 into an integer. So now a square is equal to 100 can be written as 3 into 33 plus 1. 3 into 33, 99 plus 1 is 100. So this can be written as 3 into an integer. 33 is an integer. Instead of integer, we can write as m plus 1. So like this, square of any positive integer can be written as 3 multiply a number or 3 multiply a number plus 1. This is our theorem.